Hello YouTube. Today we'll be looking at the AP Calculus AB 2013 FRQ question number 2. Alright, so this is a particle in motion kind of thing, dealing with speed, velocity, position, acceleration, etc. So just going to highlight the key details here. So we have the interval from 0 to 5 and we're given the velocity. The particle is given by this function. And the position is s of t, so that's just what they want us to use for position. And we have an initial condition, so we know it starts at 10, so at time 0 it starts at 10. So we're going to be finding speed at 2, we're going to write an expression for the position at time 5, and then on this interval, where does it change direction, and increasing or decreasing at times 4. So that's just what we're going to be looking at, so let's jump right in. Okay, so we want to find out what the speed is at, or when the speed is equal to 2. So remember that speed is the absolute value of velocity. Just a simple way to put it, if you guys don't know, it's velocity can be negative if you're changing direction, but if you're speeding up in a negative direction, you still have a positive speed value. Like when you're going northbound on a freeway and then southbound at 60 miles an hour, both ways is 60 miles an hour, but for velocity, one would be plus 60 miles an hour, one would be minus 60. So we want to find where the speed is equal to 2. So in green I wrote the function for velocity, and that was given, and you just said equal to 2. But remember, since it's absolute value, when you plug this in your calculator, make sure you do the absolute value sign. So how do you find when it's equal to 2? Well, an easy way to do it in terms of algebra, you can just subtract 2 on both sides to get the new function, and that's when it equals to 0 is the question. You can just put that in your calculator, do second calculate 0. And then for your zeros you would get these two values, and pretty much it's just saying at time 3.5-ish, for whatever, is when the speed is at 2. Alright, let's move on to the next portion. So now we're trying to write an expression for position. So that's the first part, and then we're going to find the position at 5. So, what is position? Position is the antiderivative of velocity. Okay, let's work with that. So, how do you calculate the antiderivative? Integrate. So, the antiderivative of v of t dt would give you s of t. So, how do we write that expression? Well, we have to remember we were given an initial condition. What was that initial condition? The particle started at 10. So 10 is where the position is, plus the antiderivative of velocity would give you your position. Now, what is the expression that they're looking for? Well, we'll just you start at 0 and then you go from whatever the variable is, and that's your expression here. Alright, so the next question is find s of 5. So where's the position at 5? So you just do s of 5 and put this into your calculator here as a y1 or y2 or whatever, and then just do y whatever of 5. And you would get about negative 9.207, and that is the position at time 5, and that is that. So next, did I just skip C? 1 second. Well, it looks like I forgot to write C. Well, here it is now. So let's just see what we have to do. So we're just trying to figure out where the particle changes direction from 0 to 5. And when does the particle change direction? If you remember, it's when the velocity is equal to 0. So if you had a graph, pretty much whenever the particle or the velocity hits the x-axis, here and here is when the particle changes directions. So here's like the positive, like increasing and decreasing, like the speed is positive, speed is negative, or not speed, the velocity is positive, the velocity is negative, and then here it would be like at a stop sign or something, like stop sign. That's how I remember it. There's a stop sign, and then you go the other way. I don't know. It works. So that's pretty much what we're doing. So all you do is put the velocity function that we were given at the beginning in your calculator, do second calculate 0, and find where the zeros are, and that would be your values. I'll kind of show some work here in a sec. So here's the velocity function, and we're setting it equal to 0. And that's how you would calculate it, and your answer would be 0.536 and 3.318, and those are the answers because that's where v of t equals 0, and the particle changes direction. So the first intercept we found, the velocity goes from negative to positive, and this one goes from positive to negative, just to clarify why it changes direction. Same thing when I was talking about the stop signs, and yeah. Alright, last portion. Oh, we're going this way now. Is the speed increasing or decreasing at time 4? Well, let's see here. So think of this as like speeding up and slowing down. If you're speeding up, basically velocity and acceleration need to have the same sign, so they can be both positive or both negative. If one's positive and one's negative, or one's negative, one's positive, or vice versa, it's slowing down, because think of acceleration as like your brakes of your car or your throttle, and velocity is your speed. So if you're accelerating and going in the positive direction, that means you're speeding up. But if you apply the brakes, that means your acceleration is negative, and your speed was originally positive, so you'd be slowing down. But if you're going in the negative direction and applying a negative acceleration, is technically like a throttle. Just think if they have the same signs, pretty much, it's speeding up. So using that, we need to find the velocity and acceleration. So remember, we're looking at time 4, whether it's speeding up or slowing down. So if you calculate the velocity, which was the given function at the beginning, you would find that at time 4, you would do like y1 if you have velocity as your y1. y1 of 4 would equal negative 11.476 as your velocity. So it's just saying like you're going in the negative direction. And then your acceleration is remember, acceleration is the derivative of velocity. So the derivative of velocity at time 4, you would also punch that in your calculator. You get negative 22.296. Now, let's look here. Look at the signs. Just like we were looking up here. If it's both positive, it's speeding up. But if also it's both negative, it's also speeding up. These signs are both negative. So therefore, I can't make it look nice on here, but so just again reiterating, therefore, that's therefore, speed is increasing because velocity and acceleration have the same sign and they're both negative. And that is why speed is increasing, or it's speeding up. And that pretty much wraps that question up. Hope this helped, and good luck on the AP test.